Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Last session, we did make more improvements to to the camera pivot and border and whatever, camera zoom. So I wonder what happens man, what happens if we just clip camera into area constraints? We don't do a movement anymore because the camera area constraints, they are now updated every time. Let's see what happens. So, let me move that. Okay. Okay, so far so good. Yeah, because basically, since we update the ground level slowly, and then we update the camera constraints slowly as well, so the camera constraints now already update just slowly. The border constraints, they also move smoothly into position when the ground level changes. I think that's pretty cool. It's a bit of weird movement here. Oh, it's probably fine. Oh, we really need to fix those micro stutters. It's really annoying. You scroll and there's so many stutters. It's so unsmooth. Look at this. Stutter. Stutter. It's so annoying. Stutter. Stutter. Spike, yeah. It's like every couple seconds there is a spike and something causes stuttering. That again, huge one. Huge spike. Again. I wonder why this happens. Is it loading something from disk or what is it doing? It's really bad. Boah. Something is really stalling hard here in this game. Okay, but I'm very happy with how the border now interacts. This looks really good. Yeah. Looks promising. Maybe what we can do is maybe here we don't multiply by this, but by 1. And then we add a bit of offset. Offset. Let's say we do 900 serif. Reduces border offset bit to give more room to scroll to edges. To try 0.8. Let's take the dozer and drive around a little bit here. Okay. Yeah, I think that's looking quite decent. Okay, cool. I like it. Let's clean up here a little bit. So that means we no longer need this here. We don't need that. And after scrolling. We still need it, no? I'm not sure if we need this here. Let's remove it. Okay. Okay, this looks really good. Yeah. Cool. Now regarding the, so we have two issues. One issue is something is wrong with the view frustum, right? The shadows are disappearing, and on DEF CON we also saw there's like this black at the top of the screen when the terrain is far away. Something has broken here. Plus the camera cone here on the radar looks also bad. Something is wrong with that, and I'm not sure what it is. Let's go to okay, radar, W3D radar, W3D radar. Reconstruct view box. The view box. Tactical view. Get the 4 points of the view corners. At the average set height in the map. Okay. Can reconstruct the view box given the current camera settings. World radar. Current radar cells. View angle. It also gets the zoom. So rotation looks okay. That looks wrong. Yeah. Zoom. How does zoom look? Okay, zoom works. The cone looks a bit too large, doesn't it? Yeah, way too large. Why is that? Reconstruct view box. Oh. It's not that. Yeah. I thought it is. Get screen corner world points. Maybe. Reconstruct view box. Aha. It's only updated. Okay, so get screen corner world points. Okay. Get terrain average Zs. What does that mean? Terrain average Zs. Terrain average Zs. How? Terrain samples. Compute averages. Oh. Okay. Get terrain average set. Why is it doing that? Why do we need the average Z of the terrain? See if we need to reconstruct the view box. So, if the zoom changes, view zoom, view anchor. The view box. View zoom. Draw. Build terrain texture, true. Okay, so only on zoom and on angle. Not on pitch. Not on pitch. Yeah. I think what we need to do is from the tactical view, we call a function into the radar at the right moments. Or we need to reconstruct the view box. This is only used for this checking here. Yeah. Okay, terrain average Z. Okay, let's do the following. Let's reconstruct the view box all the time. Yeah, so we just comment out this condition here. Yeah, let's not care about the conditions right now. We just reconstructed every frame, so that we can see like how it behaves when we move the camera and so on. Yeah. Okay. Fair enough. So let's go down here. That looks maybe fine. Good. So if we zoom, yeah, okay. The cone seems a bit large, but maybe it's correct. Let me go to some house here. Yeah, okay. It seems to be quite accurate actually. Let's see here. Yeah, there's the hotel or the gas station. Yeah. Okay, actually looks pretty accurate. Now there should be the bunker. Okay, it does actually work. Okay. So it's only a problem of updates. Yeah. Okay. Okay, that's good. Let's change the camera pitch. Uh-huh. Oh. Oh, that's interesting. That's very interesting. So something is not right. So we can see that here the terrain becomes black, but also on the radar we see the camera cone bugs to become like a weird, I don't know, 8. A Greek 8 also. So something is not quite right here. Yeah. So maybe there's a problem with this function here, get screen corner. World points. What does that do? Oof. What? Upper left, upper right, lower right, lower left. Screen to world at Z. Project. Screen to world at Z. Find X at Z. Oof. Get the 4 points of the view corners in the 3D world. Why does it do this here? Pause. Construct view box. So, how do we figure out why this looks so weird? How about we move it down? Yeah, let's put a breakpoint in here. 0. Top left 0. Okay, yeah. Oof. Okay, these are some wild numbers here. Minus 7,000. Let's move it up. What do we have now? Okay, these are more sane values. Yeah, okay, maybe that's maybe the issue's here. So it screws up here. Yeah, so we have a y of minus 18,000. that looks wrong. So the question is, how does it come to be? Restart. The y position is smaller than the z. Oh. Z. Ray ends. It also it's going up, isn't it? Minus 12,000. Okay, what is going on here? 1101. Screen to world at Z. Find X at Z. Find X at Z. So the Z is 47. And this Z, yeah, it can't. It's Z is higher. So it's the vector goes up in the sky and the heavens. Restart, and where do they come from? View height. Screen to word at Z. It's only used by the radar. Oh, we also have this here. Get the 4 points. Oh. Okay. So there seems to be some major bug here. Yeah. Get screen corner world points. Project the 4 corners of this view into the world. So it's definitely wrong because a ray start is lower than the ray end. So this ray is shooting up. Yeah. And the Z position is lower. Okay, why is this ray SW? S W S 0 0. Yeah. Restart. Re-end. So at 0 0, that's the top left corner, right? The top left corner is here. I don't understand how this can be. I don't understand how. Where's this shooting at, this ray? I don't understand. It's also weird that it's like the sudden position and then it breaks. Like, why is that? I don't understand. What about the next one? The next one is... It's also wrong. Bottom right. Restart 151 minus 400. Aha, there we have... There we do get a proper position. Okay, this one looks proper. Yeah, minus. Uh-huh. 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 0. Hmm. 0 0. Pick ray. 'X minus that. Okay, lock. Minus 1 1. Ray starts. Get position. 151 is that. Yeah, okay. Okay. Unproject. Ray ends. Lock 1 1. Get world space point. Ray ends. Okay, so this so far looks good. Well, they look almost the same here. Ray start, ray end. So now that's near 0 for some reason. How? Normalize. Make unit vector. I wonder if there's an error here. So now Z is up a tiny bit. Get depth. Now it scales it and then it becomes super huge. It's just length. Yeah, and so it goes up now. I wonder if it's a precision issue here, this one. So the numbers get quite large, into the thousands. And so now we deduct it, and maybe... That's weird. But there should be enough precision here. How does this look on a healthy value? Like this. Ray starts 8:01. Okay. Ray ends 328. 32875. Okay, so here the Z is a little bit smaller. Here it's a little bit larger. Unproject. Get world space point. And so here Z is going down, but it's very close to 0. Now it normalizes, so it's minus 0.33. Okay. And then it scales it. Everything is okay. How does this unproject work? View plane. Unprojects. Unproject a point from the view plane to world space. The given point is assumed to be on the view plane at Z minus 1. Assumed to be on the view plane at Z minus 1. Okay. The 3D world space point that this represents will be returned in dist. Dist will be filled in with a 3D world space point that the given point represents viewpoint point of the view plane to be unprojected. Point. What is this doing? Max. X. View plane. Huh. Is it? Three two eight. 363. Restart, good position. Viewpoint. Viewpoint. Right now I have no clue where the error is. We would need to find there must be some value somewhere that incorrectly flips to some unexpected value. Probably something obvious, some obvious math issue, but I don't know where to look. But it's somewhere here or in one of the child functions. It could be in here, it could be in there. I mean, there's also multiple things going on here. Could be also a problem here with those view planes happening before, right? So that these guys are already bad. What is this guy doing? Oh, that's not doing too much. Translate a pixel chord at the upper left to the W3D logical chord system used. Okay, I have no idea what that means. On projects. It's not used much. Log X, log Y. Get world space point. Get pig ray. Something is wrong, but what is it? Just lengths to reach far clip plane. Okay, I mean, this is fine. That's also interesting that here it deducts it and then it adds it again. Huh. Huh. World space point. Normalize. So it just builds a vector here and then it turns it into position again here. Yeah, okay, fair enough. becomes positive number. If you play min xu. X, Y, Z minus 1. Minus. I have no clue what this is. The view plane. This represents review turn. View plane. View plane looks exactly the same, or at least similar. So that's maybe not a problem here. Point X, Y, Z. Transform. Dist. Z is 138. So this one is smaller than this one, isn't it? No, it's a bit, yeah, no, it's a bit bigger. It's a tiny bit bigger than this one. And that's why it's positive now. Yeah, so the problem is that this Z value here in ray end, that this turns positive. That is the problem. Why does it become positive? Yeah. Why? So that will be at 41 rands. But it is lower. No, it's not. It's higher now. Yeah, so the ray end is higher than the ray start. So that's a problem. How do we solve that? This one seems to always return -1 and 1. So that seems to be consistent. Yeah. So I assume that these values are okay. And this one should also be okay. So I suspect the error is here in unproject function. But maybe... min x plus this, min y plus viewpoint. Viewpoint x minus 1, y1. Why does vector 2 have 3 values? What is this? Oh, okay, it's just an alias. It's either x or u or y and v. Ah, I see. So it's x, y, and so minus 1, 1. Okay. Minus 1, 1. It looks like the resulting point is I don't know. So it's transform set. Oh boy. Maybe there's some error here. Let me ask ChatGPT about this function. Can you explain this function and tell if it is correct? Can you explain the C++ function and tell if it is correct? Let's go through this function carefully. What it's doing, why, and whether it's correct. Converts a normalized device coordinates point on a view plane. Range -1, 1 in x and y. Z minus 1 back into world space using the camera's transform matrix. Compute the size of the view plane, the width and the height of the view plane and whatever coordinate system. Map from normalized device to the actual view plane. Viewpoints X. Mapping is correct. Near plane and camera space. Looks down the z-axis, which was typical in older right-handed coordinate systems. Transform from camera space to world space. Depends on the meaning of transform. If transform is a camera to world matrix, the camera transform in world space, then this is correct. If transform is a world to camera matrix, the view matrix, then this is wrong. It would need to multiply by the inverse of the matrix to go back to world space. The inverse. World to camera matrix. Camera to world matrix. Okay, fix that. This assumes the camera looks down minus Z. Yes. If the engine uses plus Z forward, then this will be inverted. Matrix direction. The correctness depends on whether transform is a view matrix or the camera transform. Camera's world transform. Camera's world transform. I assume that it is transform. It doesn't say. Let's see what it is. Camera class transform. Where's it? Camera. Oh, it's part of render object class. Camera. Okay. Camera. Update the inverse camera matrix. Camera inverse transform. Device to world space. Device to world space. I think it's a correct matrix. Yeah. We can make a test here. We can put the camera inverse transform. Transform to view space. Okay, now it's correct. It's correct. Oh boy. transform. View plane mapping, correct math. Depends on handedness. Depends on whether it's camera world, yes. One typo. Reasonable and clear for 1990s era engine code. Yeah. Nice. Function correctly unprojects a 2D view plane coordinate back to world space. If the camera looks down, minus that. And transform is a camera to world matrix. The camera to world matrix. It's a camera to world matrix. Okay, so it seems that this is correct. But then what is the error? View height, left, right, top right, bottom left. X, bottom right. Bottom left. This looks wrong here, doesn't it? Like if it's left, then why is it adding the width here? That looks wrong. Let me ask ChatGPT about this function. Please check if the following function is correct. Following function is correct. To me, it looks like there's error here, here, and here. Yeah, so this here should be here, I think. The following function is correct. Almost right at first glance, but there are a couple of subtle and likely serious coordinate mix-ups. Step by step, getting screen corners. Width and height. Assigning screen corner coordinates. Let's map this visually. Here. Yeah. Wrong comment or wrong label? Swapped. Yeah, I agree with that. Projection step. This is logically correct if the 2D screen corner coordinates are correct. Yeah, okay, let's do that. So we take this and we put that here. May do that. Let's comment this out. I find this wild. How did this work then to begin with? So now left is here, Y, yes, and then right is this, yeah. So this now looks correct. Let's see how that looks. That's wild. How did this ever work then? That's baffling. Uh, oof. Oof. What is this? Wow. Okay, it's bugging more. Bottom left, bottom right. Maybe. How's this used? Box. Okay, so these are getters. Left, right, left, right. Left, right. That's wild. Screen bottom left. Why was this working here? What is going on here? I'm confused. What? Screen bottom left. Yeah, this looks right to me. Why? Maybe maybe they have a tier flipped as well. That could be worlds. XY. Radar XY. Okay, how about we say I mean, what we can do is we can just flip this with this, right? So here this is lower right, lower left. Box. Zero, 1, 2, 3. Okay. Okay, I think that will do it. Yeah. Okay, I have no idea why this was swapped then. But that should work now. Okay, but that doesn't explain the bug, so it was just like incorrectly named here. This was labeled as left but was right, and this was labeled as right but is left. So yeah. Okay, so the cone looks good again, but it won't fix the issue we are having. Yeah, it's still bugged. Yeah, okay. Yeah. Okay, but okay, we have that fixed, but it doesn't fix our problem. Okay. What else could be the problem? Get origin. Nah. 0, 0. X, Y, X, Y. 960. Because of the control bar. Oh boy, what is the problem here? So we can observe the problem in numbers, but we don't know where exactly it comes from. Like which math is responsible for breaking this? That I don't know. Oh, yeah. X, Y, minus 17,000. I mean, yeah. So restart is. S00, pick ray, S. Let's ask about this function. What about the following function? Does it look correct? Excellent. Classic W3D picking routine. That's a bullshit. Quite clean for its era. Let's break it down. Compute is world space picking ray that starts at the camera position. Classic. And passes through a given screen pixel. Also classic. Ending at the camera's far clip plane. This likely converts pixel coordinates 0 width, 0 height to normalized logical screen coordinates minus 1, 1. Yes, it does. That matches the comments. Correct. Restart. Camera position. Correct. Compute world space point on the plane. Calls the camera's unproject the same one you posted earlier. As we discussed before, that function maps. Correct. Z minus 1 is a near plane. If so, ray end now holds the world space points on the near plane. This makes ray end a unit direction vector pointing from the camera towards the pixel's world position. Correct. Scale to far clip distance and offset. camera depth, likely far clip, correct behavior. Potential pitfalls. Coherent-handedness. That is probably good. Get depth, meaning must return clip distance, not near. Yeah. Normalize then scaling. Fine as written, but slightly redundant if you could directly scale by the distance between near and far. Yeah. Origin offset correctness. Subtracting M origin X and M origin Y assumes origin fine if consistent with running setup. Logical flow. Perfect. Perfect. Function is correct. Okay. Avoids precision loss. Yes, show me that. Yes, show me that. It's what kind of numbers would we expect precision loss to be critical? Precision safe version. Computer normalize the ray direction. Ray denormalize. Ray denormalize. Far clip is large, say 100,000 more. You're adding a large and small number. How long is the far clip then? Let's see. Get depth. 3D camera. 1200. It's not that much. Yeah, maybe have it normalized. Slight jitter. We're completely unstable. Reindeer. Yeah. I don't see evidence that this is. I do like this, that it takes the direction and origin. That would be good, but yeah. When I pitch the camera closer to the terrain, closer to the ground, pitch the camera closer to the grounds, but still looking down, still looking closer to pitch the camera closer to the ground, but still look at the ground, not slightly at a low angle, then the ray ends coordinates has a larger z coordinates than ray start, which is unexpected. With the original code as shown, when I pitch the camera closer to the ground but still look at the ground at a low angle, then the ray end coordinate has a larger z coordinate than ray start, which is unexpected and wrong. Why would that happen? Thinking. Oof, must think hard on this one. That shouldn't happen. Below I explain the most likely causes. Short answer: when you pitch low, usually means the unprojected result is in the wrong coordinate sense. It ended up above the camera and world Z, which in turn comes from one of the root causes. Unproject is using the wrong transform. It's not. Unproject assumes the wrong Z sign. It's not. The transform routine used, transform vector treats the input as a direction. No translation. The transform routine used, transform vector treats the input as a direction. No translation, rather than a point. A screen Y handed a mismatch? Nah. What? Nah. Transform vector applies translation. Some libraries have transform vector, rotates a vector, no translation, versus transform point. Applies rotation. If transform vector does not add translation, this will lack camera position offset. Transform vector. Okay. Transform vector. What's the right way to do this? That doesn't give much confidence here. Transform a vector by the inverse of this matrix. Transform vector. Transform vector. Try flipping the Z. Check screen Y convention. Wrong matrix direction. It's not that. Transform point. Let me give him a transform vector function. Here's a transform function. Perfect. When you tilt the camera down, let's go through it carefully. Affine transform would play. So this does include translation. Acts like a transform point, not a direction transform. If transform were a camera's view matrix, then this function would move the point further into camera space, not out of it. The inverse of the view matrix. I think it's not. I think he's not getting the right conclusions here. No. I mean, we can test what happens if I use the inverse. So here we have this transform, and let's use the other one. Yeah, let's use the inverse. Where's it? Here. I don't expect that this will fix anything. It will probably make it worse. Yeah. Classic W3D codes. Yeah. Okay, now it's the wrong way around. Okay, well, let's see what happens with the pitch now. It's the same issue. Huh. Interesting. Let's say the transform matrix is correct. The problem is elsewhere. Point Z. Okay, let's change that to a plus. Yeah. +1. Okay, let's see. I don't think their suggestions from chat make sense, but I don't have any better ideas right now. So might as well just do some tests here, see what happens. No. But I think it's stupid. Yeah, that also flips it. That doesn't help. Oof. 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 Oh boy. That's really bad. I think it's... No, it's not that. No. I think these are... What else could it be? Yeah. View plane. Yeah. It's probably something very stupid. W3D screen coordinates -1 to 1. We need to do some conversion. Vector camera to word space point. Yeah. Make unit vector. position. I don't know. There must be some logical explanation for this issue. I just don't see it. I don't see it. I still don't understand this log X, log Y. Viewpoint. Translates. So at 0, 0, at 0, 0, hello? The log will be minus 1 and 1, okay. And then at this one, would it be different? 1, 1, okay. 1, 1. 3, 2, 8, 7, 5. Yeah, so the rate start again is larger. Yeah. Minus 407. Minus, okay, that's actually correct, yeah. Position is 160 Z, okay, and then 160 ray ends at, why does the ray end at 60? Ray starts. One, 4, 8. Okay, that is still going down. It is going down. X, Y. Maybe the problem is that the far clip plane is not long enough. Could that be a problem? I don't know. So let's say we go to camera class, get depth. Get depth. Get depth. Set far. Okay. How's this set? Get depths. Who's setting that far? Okay, it initialized to 1000. But it is 1200, so someone is changing it. Paranoid. Set clip planes. Someone is calling this, I guess. Configure camera. There we go. Far Z. Okay, how about we set here? Let's set some, I don't know. Let's set 120,000, why not? Let's see if that changes anything. Far Z. Oh, there's also extend far Z when we pitch up for real zoom cam. Draw entire terrain. Oof. Okay, it looks different now. Interesting. Looks also buggy. But looks different, Buggy. Oh boy. Okay. Yeah, I don't know. Yes, that's... Maybe near Z is a problem. How big is that? How big is near Z? Ten. Well, it's close enough. Yeah. I don't know what the problem is here. Well, let's take a break here. I think we made some good progress, but there's still so many open questions. Yeah, needs more investigations. Okay, good. Then I will end it here. Wish you a great day or night. Until next time. Goodbye.